Alright, in this video, I'm going to show you how to find the area between two z values. Alright, so in this particular example, it says find the area between two z values within one standard deviation of the mean. Now, according to the empirical rule, you already know what this answer is. So within one standard deviation of the mean, you should probably already realize, using the empirical rule, that is 68%. Because within one standard deviation is between the -1 and the +1 on the horizontal axis. So they want to know what's the area between this. Now, according to the empirical rule, it should be about 68% because this is 34% and this is 34% as well. But we're going to use the z table to verify that this 68% is accurate. So the empirical rule states that 68% of the data will fall within one standard deviation of the mean. Now, using the z-table, we're going to figure this out. Now, here's a great way of looking at it. Alright, so here he says area between -1 and 1. This is what we have here. They first found the area that was to the left of 1. Area to the left of 1 ended up being 0.8413. And that's what we're going to do. The first thing we're going to do to find out the area in between this is first we're going to find the area to the left of z equals 1. So that would be everything here, right? So we're going to find the area to the left of z equals 1. What do? Well, you should go to your z table and look for 1, right? 1. 1.00. 1 is equivalent to 1.00. So let's do that. We're on the positive side. Notice that we have 1.0 here. 1.00 corresponds to this 0.8413 right here. Alright, so 0.8413 will correspond to the area that's to the left of z equals 1. So let me draw that again. To the left of z equals 1 will be everything here. So that makes sense because that looks like more than half of the bell curve. So this area is 0.8413. Now let's find the area to the left of -1. Alright, the area to the left of -1 would be everything here in this area. We want to be able to take this area off so that we can find out the area that's between -1 and 1. Again, our z table will tell us what's the area to the left of -1 would be this area here. So we want to take this part, subtract this part from all of this, right? We originally had all of this when we looked at z equals 1, but we want to come back and subtract this area from this area in blue. That way we will only have the area between -1 and 1 or within one standard deviation of the mean. So if you go to the table, the area to the left of -1, so we'll have to go to the negative side. The area to the left of -1 is 0.1587. So that little part is 0.1587. So let's recap. The area to the left of z equals 1 or 1.00 is 0.8413. So all of this is 0.8413. However, I only want to know the area between z equals -1.00 and 1.00. So I need to subtract this area. Now I just found out that this area is 0.1587. So to get the area in between these two numbers, I will subtract 0.1587 from that big area of 8413. So 0.8413 minus 0.1587 will give me the area that's in between, which is in green right here. So get that, you should get 0.6826. Now we predicted that it would be about 68% according to the empirical rule, right? So we are really close, because this is 0.6826 or 68.26%. Alright, I want to try another example of finding the area between two z values. So let's find the area between z equals 1.28 and z equals 1.96. So again, we have an example. Always draw a picture and shade. So I'm going to draw my bell curve. Again, that's 0, 1, 2. We have -1, -2. That's good enough since we're dealing with 1.28 and 1.96. 1.28, let's say 1.28 is about here. Let's say that's 1.28. And 1.96, let's say it's right here. And we want to find the area between. So we want to find this area. So a very small area, as you can see. So definitely the area will not be more than 50%. So just this little part here. Alright. Now, first thing we're going to do, I always go to the area of the higher z first, because that area would be, if we go to the table, it will tell me the area that's to the left of 1.96. So the table, if we go to the table, find z equals 1.96 on the table now. So if you go to the table, so that's what I want you to do, is find 1.96 without me showing it to you. And that way, I'll know that you know what you're doing. So if you go to 1.96 on the table, what is the area to the left of 1.96? Z equals 1.96 corresponds to an area of 0.9750. So that means all the area to the left of this, which is everything here, right? All of this, definitely more than 50%. And indeed it is. It is 0.9750. However, we don't want to know the area just to the left of 1.96. We just want to know the area that's between 1.28 and 1.96. So that's why we're going to find the area to the left of 1.28. If we find the area to the left of 1.28, we can subtract, right? If I find this area here, I can subtract it away, right? Get my horizontal axis back. I subtract it away, and that only leaves me with the area between 1.28. So I got to turn around and subtract. So I got to subtract all of this, right? So that's why I need to find this area. So I only end up with this area. This is all I want right here, right? This is all I want. It's this little piece. So I got to subtract all of this. So that, for that reason, we need to find Z equals 1.28 on our table and find out what does it correspond to. Alright, so go to your table now and figure out what does 1.28 correspond to. So, if you said, or if you found that it was 0.8997, then you are correct. Now, what do? Again, we need to subtract this area from all of this area to just get this area, right? So that's why we're going to subtract. We're going to go 0.9750 minus 0.8997. And remember, this number should be very, very small, right? Because it's only just this little piece of that bell curve, right? It's only this in green. So when we subtract that, we get a very small number of 0.0753. Alright, so this is just 0.0753. Small number like we predicted it would be, which is about 7.53% of the bell curve. Alright, this concludes my video on how to find the area between two z values.